So hello everyone, in this video we'll be covering solution for question 3 of endsem. So let's see the question and it is the first part which states that compute mean, median, mode and standard deviation for a given small dataset. Explain when each measure is appropriate. So let's first see the definition of mean, median, mode and standard deviation and when it is useful, and then we'll be using an example to solve all these. First is mean. It is the arithmetic average of all numbers in a dataset. It is calculated by summing all values and dividing by the total count of values. Appropriate use, best of interval or ratio data that is symmetrically distributed without extreme outliers. It provides a good overall sense of the central tendency. Next is median, the middle value in a dataset when all values are arranged in ascending or descending order. If there is an even number of values, it is the average of the two middle values. Appropriate use, most suitable skewed distribution or data containing outliers, as it is less affected by extreme values. Compared to the mean, it is represented a typical value. Then mode, the value that appears most frequently in a dataset. A dataset can have one mode, multiple modes, or no mode if all values appear with the same frequency. Appropriate use is applicable to all levels of measurement, nominal, ordinal, interval, ratio. It is particularly useful for identifying the most common category or value in categorical data. Next is standard deviation. Its definition states that a measure of the amount of variation or dispersion of a set of values is. A low standard deviation indicates that values tend to be close to mean, while a high standard deviation means values are spread out over a wider range. Its appropriate use is essential for understanding the spread of data around the mean in normally distributed data. It's crucial for accessing data consistency, reliability, and comparing variability between different datasets. Now let's see an example. For dataset x1, x2, xn, mean will be 1 by n summation of I. It uses all values and is sensitive to extreme outliers. Median middle value when data are sorted for odd n, it is a center element for even n, the average of two middle elements. It is robust to outliers and preferred for skewed distribution. Mode, value that occurs most frequently, suitable for categorical data or the finding the most common value. Standard deviation formula is square root of 1 by 1 upon n minus 1 summation xi minus mean ka whole square, which has sample standard deviation. It measures spread around the mean. Larger standard deviation means more variability. Example data 2, 4, 4, 4, 5, 5, 7, 9. Here mean will be summation of all this, which is 40, and total number of data. So it is 8, so our answer will be 5. And median, since there are mean, so average of middle two values, which is 4 and 5. So 4 and 5 equals to average of 4 and 5 will be 4.5. And modes will be 4 and 5 because 4 appears 3 times and 5 appears 4 and 5 because both appears 3 times, and standard deviation is approximately 2.14. Use mean and SD when data are roughly symmetric with no extreme outliers. Use medium and IQR when data is skewed. Use mode for categorical or multimodal data. Now let's see the next part of this question, which is errors and artifacts. It states that what is the difference between error and artifacts in data cleaning. Explain any two imputation techniques. Now let's see the solution. Errors means incorrect, inconsistent or missing values caused by measurement problems, manual entry mistake or system bugs. Example, age equals to 250, negative salary or a missing value. Whereas artifact means artifact patterns introduced by data collection or processing, not reflecting true behavior. Example, duplicate records created during merging, periodic spikes due to sensor reset, or rounding all times to 00 seconds. So two imputation techniques is mean median imputation, replacing missing numeric values in a feature with the mean or median of that feature. Median is better for skewed data since it is robust to outliers. And next is k nearest neighbor imputation KNN. For a record with missing value, find k most similar records based on the other features. Use this average or majority vote of their values to fill the missing entry. This preserves relationship among variables. So that's it for this question. We'll be covering next question in another video. Thank you.